Hello everyone, we are from group Binary Matching. Today we're gonna present about our project. Let's get started. Project overview. Binary Matching is a game designed to improve user familiarity with binary numbers. The player is presented with a random binary number, which is shown by LEDs. The goal is to correctly match binary number with their decimal equivalents. Project objectives. First objective is reinforce binary number comprehension. We like to help user understanding how binary numbers represent value in base 10 by practicing real-time conversion and introduce number system in a fun way. We also like to provide a non-intimidating gamified introduction to binary system for students or beginners in computer science. The second objective is understanding of Arduino concepts and understanding how to use every component in our project kits such as keypad, buzzer, and potentiometer. The third objective is familiar with C++ programming language. Let's see our circuit overall. We use LCD, potentiometer, buzzer, LEDs, keypad, and button. Let's talk about each component. The first component is a I2C LCD display. Purposes to display game information like timer, instructions, and results. We use pin A4 for SDA and A5 for SCL. A4 and A5 are dedicated to I2C communication, acting as the SDA and SCL lines. The next component is potentiometer. Purpose is to use for user to randomly adjust and generate the 4-bit binary number to convert. We use pin A0 for potentiometer because A0 is an analog input based for receiving analog value from potentiometer. The next component is a buzzer. Purpose to provide sound feedback such as counting down beeps and reload tones. We use pin A1 for buzzer because we use the function tone which require analog output, so it makes different kind of tones. The next component is binary LEDs. Purpose to display the 4-bit binary that user has to convert. From MSB to LSB, we use D0 to D3. D0 and D1 are normally used for IX and TX, but we are not using serial communications and we are like out of pins, so that's why we use D0 and D1. Next is a win-loss LED indicator. Purpose to light up to indicate whether user is correct or wrong. For win LEDs we use D8, D13, and for loss LED we use D12. Next component is a button. Purpose to allow user to start and reset the game. For start button we use A2 and for reset button we use A3. There are leftover pins and analog pins can also act like a digital pin. That's why we use A2 and A3. The last component is the keypad. Purpose to allow user to input their guess and set the timer. For the row we use pin D8 to 11 and for the column we use D4 to D7. So we implement our circuit by using Tinkercad website. Next is the code part.
Okay, so before I take you to the code, we'll start off by taking a look at the flowchart first. So, the beginning of the program will receive the number from potentiometer and it will check if the start button is pressed or not. If not, so it keeps receiving the number from potentiometer, but if yes, so it will tell user to input the time. And after that, it will check if the time is input or not. If not, it keeps asking for the time. But if yes, so it will show the binary on the 4 LED that is on the circuit and start counting down, and it will check if the time ran out. If yes, if the time ran out, so user lose. But if no, it will check that if the user has input the answer or not. If not, so it will keep counting down and check for the time. But if user input the answer, so it will check if the answer that user input is correct or not. If it's correct, so user wins. But if it's not, so user lose. And when it comes to the phase where user has win or lose, it will check that if the reset button has been pressed or not. If not, so it remains it states. But if the reset button has been pressed, so it comes all the way to the start. And then it repeats every single steps again. And that's it for the flowcharts. Okay, well, now it's time for the code. So we started off by including two libraries, which are keypad for keypad and liquid crystal for LCD display. And next, we define all of the hardware's pins into an easier name for easier to recognize, like potentiometer, where we connected it into A0. So we name it as POT, just for easier to use. And on the line 11, we define the four binaries LED into an array of four contains the pins 0 to 3. And next, we configure the keypad just like how we did in the lab. And on the line 27, we define the address for LCD display where the address is the hex number of 27. And on the bottom part, we prepare the variables to control the games. For example, display value is the number to guess. The game phase is to check whether the game is start or not. Okay, this is where we set up the pin modes and initiate the initial values of it. For example, LCD has to show the phase press start, and all of the LEDs has to be off first. Okay, here's the beginning of the game. So the first line 61st to 65th is where the user hasn't pressed the start button yet, and it will keep receiving the analog value from the potentiometer. And then I use the function map to map out the analog input 0 to 1023 into 1 to 15 and store it into a variable. So this value 1 to 15 is from the 4-bit binary, which is up to 1111, which in decimal is 15. And then on the line 68 is where the start button has pressed. The reason it has to be low because we connected the button as an active low. So when we press it, it returns low. Then it will tell the user to input the time on the LCD as on the line 22. And on the line 75th to 91st, it will get the keypad input just like in the lab. And after finished getting the time, the Boolean game phase is now set to true. And as you can see, we use the built-in function millis for the variable start time and last display update. This function returns the number of the milliseconds since the board has started running, and what we use it for, we'll talk about that later. Then on the for loop is where we show the value from the potentiometer and convert it in binary and show it onto the binary LEDs. Okay, here inside the game phase, we start by calculating how much the time has passed since the game began. Here, we're making a new variable named elapsed and using millis subtracting start time, so we get how long this particular round has been running. And we then calculate the remaining time by subtracting the elapsed seconds from the total time. This value is used to display the countdown and control the buzzer speed. Now we move on to updating the display from the countdown timer. And on the line 115 is where if 1 second has passed since the last LCD updated, we proceed to update it again. Like 1 second has passed, so we update 1 second. Moving on to the line 124, here's the interesting part. It is how we increase the speed of the beeping sound as the timer counts down. First, using the map function, we adjust the beep interval. At the start, the beeps are 500 milliseconds apart, so it is still slow. And as the time is approaching 0, they speed up to almost like 50 milliseconds. And next, if the time since the last beep has exceeds the beep interval time that we have mapped, so the buzzer beep then update the last beep value by using millis again. So this is how we're making the beep faster as the time is running out. So next, on the line 131st, if the time remaining is more than 0 and user still hasn't input any answer, so it's getting the input from the keypad just like how we did in the lab. And if user press enter, which we set to D on the keypad, We set the Boolean input received to true and convert the input number from string to integer, then check if the input is matched with the correct answer or not. And if yes, it goes to win function, but if no, it goes to the lose function. And on the line 159 is where the user hasn't input any number and time has ran out. So it goes to lose function as well. Okay, on the win function, it clears the LCD and print you win on the first line. And then it turns on the win indicator LED. And then it plays a celebration sound using the buzzer. Finally, it calls the wait reset function, and we'll talk about that later. So here's the lose function. It does just like how the win function does, but it just shows you lose, and the sound will be different. It will beep like a lose sound, and wait for reset again. And here's the wait reset function. So it will print the press reset on the bottom line of on the LCD, and then it will wait for the user to press the reset button. And if user press the reset button, it will it will clear everything on the LCD and show press start, and then go back to the main function again. And this is the end of the code. Okay guys, I will show you the demonstration of this project. First, I will introduce you guys into the components first. So this is an LCD display used to display everything on the game. This is keypad used to input everything like timer and answer into the game. This is start button, this is reset button, this is buzzer, this is win indicator, the green one, and the red one is lose indicator. And four of these LEDs are the LED that will show you the binary number. This potentiometer used to generate the number. Okay, that's it. So let's start the demonstration. First of the game, you have to adjust the potentiometer to generate some random number, and you press start. And the program will tell you to set the timer. So in this case, I will set to 20 seconds and starts. Okay, in this case, it is 8. No, it is 4. Sorry. And if I input 4 and I press enter, so it tells you that you win and the win indicator is on. Okay, let's press reset and start it again. This time I will try to lose the game. Start, set the timer, I set to 20 seconds again. Okay, start. Okay, this case is 2, but if you want to clear and input the wrong answer, you can press this to clear the answer, and I will try to input like 9. If I enter the answer, so it tells you that you lose and the lose indicator is on. So I reset again. This time I will show you if I let the time run out, what will happen. So I start, I set the timer to 3. If I press start, so it will beep faster and faster, and lose if you don't input the time, if you don't input the answer by the time ran out. Well, that's it for the demonstration. Alright, before we wrap up, we would like to acknowledge 2 key resources that helped us during development. First, we learned about the use of millis from the official Arduino documentation. This function was essential for handling non-blocking timing in a project, allowing the countdown, buzzer, and screen updates to work together smoothly without relying on the delay function. Second, we refer to documentation for the Liquid Crystal I2C library. This library made it easier to control the LCD screen, especially for setting cursor positions, clearing the screen, and updating text efficiently. Apart from understanding how to use these tools, all the design, logic, coding were created independently by us, ensuring the work truly reflects our own understanding and effort in the class. Okay, so here's the contributions. So, this project was developed entirely to our own efforts and collaboration, without copying or referencing any external source code, and without the assistance of AI-generated content. While we refer to some official documentation to understand specific tools used, all design decision, coding, and implementation were carried out independently to ensure originality and thorough understanding of the underlying concepts. So here's the ending of the presentation. Thank you.